Welcome to the music group demo room. We'll get started now. We recently joined the music group along with a number of other companies, Midas, TurboSound, etc. We're specifically going to be talking about Labgruppen, Lake, and Tannoy today. And I'll start out talking about some new Tannoy products, and then we'll be talking about some new Labgruppen products as well that are new for InfoComm. If you're not familiar with the history of Tannoy, Tannoy started many years ago. It's one of the oldest loudspeaker companies in the world. They got heavily involved in the studio monitoring market back in the 40s, and pretty much anything from the 60s, 70s, and 80s that was popular music probably was mixed or mastered on Tannoy studio monitors at one time or another. Certainly all the Beatles albums, Pink Floyd, a lot of famous acts from back then were still the choice amongst professional recording people for mixing and mastering monitors. About 2 decades ago, Tannoy took that studio monitor technology and applied it to other professional markets, such as commercial sound, ceiling speakers, etc. And now we have a huge range of products for the professional audio market. Now, the Tannoy Duel Concentric monitor pretty much set the world on fire, and that's why they were so popular in the monitoring business, was this dual concentric driver. And what the dual concentric is a way of taking a low frequency and high frequency device, putting it into a single driver structure, if you will, and that is a full range loudspeaker. And the essential driver hadn't changed in many, many years. And last year, we totally redesigned it and came up with a new unit that uses a single magnet structure for both the low and high frequency devices, and has some further benefits that I'll get into in a minute here. The older device fired through the low frequency driver magnet structure, and we'll see that here off to your right. You can see a high frequency driver structure, an element, firing through the low frequency device. And so this was essentially a high-frequency device and a phase plug-in waveguide firing through a low-frequency transducer. What we did was we merged those two to a single magnet structure, and this allowed us to gain improvements in a couple of different areas. The biggest thing was this reduced the length of the waveguide, or the depth of it, and this gave us the ability to start the flare more rapidly and control the high frequencies better. The key thing we wanted to improve was have more consistent coverage at higher frequencies. It also gave us some other benefits, but here you can see the more aggressive flare. Immediately we're able to come out and control those high frequencies, get more consistent coverage. Well, what's that mean to you? If we look at our previous device, this is a CMS 801 DC, if we were to place a microphone directly below that loudspeaker, it's on axis. And that's the curve you're seeing at the top here. So that's the on-axis frequency response. This is typically what you see as a measured frequency response. The red curve is at the edge of the coverage pattern. Typically, our devices are approximately 90-degree conical pattern. So 45 degrees off axis to one side is at the edge of that coverage pattern. As you can see, the response of those two curves is very similar until you get to higher frequencies, and then it starts to roll off. Ideally, what we want is those curves to look absolutely identical. What that means is standing here will sound exactly the same, standing here directly below the speaker, but the difference is as I get farther and farther away from it, the level's going to drop. So in a properly designed distributed ceiling system, for example, if I do everything right and I have a speaker behaving well, then I can walk throughout a large area and not notice when I'm in and out of coverage of a speaker. It's all going to sound the same anywhere I am. And that's the goal that we're striving for. This is the new device. And so we've made huge improvements. We've gone from being off-axis 10 dB down at 10 kilohertz to now we're only 4 dB down. And if you look at this curve, the red curve follows the top curve past 16 kilohertz. So we are now maintaining constant coverage past 16 kilohertz, which is truly spectacular in this industry. There's nothing else in the market that's even close to this. And so we're getting very close to producing an ideal transducer. As an example, The previous delay at crossover, so the path length between the high frequency and low frequency device, was 170 microseconds. Now that's a very short amount of time, but at crossover, it means that the same sound coming out both the low and high frequency devices is delayed by 170 microseconds, and so there's some smearing that occurs. The lower that number, the more natural something's going to sound. The new device is down to 60 microseconds, so it's 1/3 the number that we previously had for the amount of delay between the low and high frequency devices. So we're really getting very close to an ideal transducer where all sound is originating from the transducer at the same time. So it's very close to an ideal full range device.